Katie Levy.
And I'm Shelby Cohen.
And we're both here from Intuit from San Diego, California. We're really excited to be here today.
And I'm really excited because last time we spoke at a conference, Katie lost her voice the morning of the conference. So today we both have our voices and we're excited to get started.
So I work on TurboTax, and before I was working on the mobile app for TurboTax on the Android app. People are really surprised you can file your taxes on your phone. And then more recently, I switched over to more of the back-end services for TurboTax, working on Spring Boot applications.
And I'm in the developer productivity organization at Intuit. So I lead cross-division engineering efforts to provide seamless development for all of our products at Intuit. So Katie's product that she works on, TurboTax, and also Mint and QuickBooks.
So today's presentation will be successful if you take away some key techniques to influence change, and all through the lens of how we influence change at a 9,000 employee company that's over 30 years old by introducing Kotlin and functional programming. So a little bit more about Intuit. It's a 9,000 employee company with 19 locations in over 9 countries, and it has over $6 billion of revenue per year with over 50 million customers per year.
So most of you know JetBrains open sourced Kotlin in 2012, and the first stable release was in 2016. Our journey started in 2017 when we started working full-time at Intuit. We attended a functional programming meetup where we learned about functional programming in industry for the first time. In 2018, once we heard about the language, but we had never used it, we started playing around with it outside of work and quickly saw the benefits and how much we loved the language. After that, we wanted to use it in our everyday development at work, so we tried to get our teams to use it and introduce it to Intuit. Now, 2019, Intuit is using Kotlin in a lot of our apps, in our Android apps, our server-side Spring Boot apps, AWS Lambdas, and more. So what is functional programming? It's when you treat your code like mathematical equations. So with the same input, you have the same output with no side effects. It's when you compose smaller functions into larger functions. It's when you avoid shared state and mutable data. And it's really good for multi-threaded applications. We found that functional programming was really helpful to improve the quality of our apps in general, and Kotlin was a great way to teach functional programming. It can be really scary and daunting at first, and people have this idea of what functional programming is, but today we're gonna break it down for you and show you how we taught people at our company what it was.
So these are the 8 key techniques that we're gonna walk you through in this presentation and how we specifically use it on our teams and then got larger to the whole company. So the first step is you really have to find your passion. You have to find something you're so excited about, you could talk about all day, it just makes you so energized. And for us, that was Kotlin. We found that Kotlin solved all the main pitfalls that Java had. It was so easy to write, it was so fun to write, it was easy to read, it was so concise, it was safe with the null safety, it's interoperable with Java, and then it's also tool-friendly with all the tools we're already using today.
So once you find something you're passionate about, you're gonna want to share that passion with other people and socialize the idea. What was my experience like? I mentioned I was on a developer productivity team. So we build internal applications, and this is a really great place to try out new technologies. My experience was actually really easy to add it to our Java Spring Boot app. I wrote a feature that I was already going to develop that sprint in Java in Kotlin instead to prove to my team why it was a good idea to use it. After I did that, I wanted to bring the whole team along and get everyone coding in Kotlin feeling comfortable. So we converted all of our Java data classes to Kotlin data classes. Throughout the way, any problems we ran into, we created learning resources just for our team so we could document any issues we ran into, and it also empowered every team member to feel like they were an expert in a specific part of the language.
That's crazy because my experience was totally different, but I, at the time, was on the Android team. You would think introducing Kotlin to the Android team would be so easy, but we had some engineers on the team who had been coding in Java for over 30 years, were so comfortable with the language, they knew what they were doing, they kind of were like, why do we need to add this new language in? Why do we need to change our whole style of programming? And so I really had to break it down to them in different presentations on like, these are the key features that I love, and this is why I think it's beneficial for you to start learning the language and use it in our application. We would also do some different group coding where we would do live coding on refactoring Java code into Kotlin or writing new features and classes in Kotlin. It really taught everyone together and got us to discuss and socialize the features and why we like them. Even at that point, there was still some hesitancy, some people wondering why do we need to use this language, and discomfort with the whole foundation of the language. And so we had to do a group training course to really get everyone on the same page of this is how you use Kotlin, this is how you use the features, this is the benefits of it, and that really got us going in the right direction.
Now, there's a lot that Kotlin has added on top of Java, so we had a lot of things to socialize. We're not going to go over all of them today, but some of the bolded ones are different parts of Kotlin that we started out with. One of the first features we fell in love with that we know most of you here probably also fell in love with was null safety.
So who has had a null pointer exception? Yeah, pretty much everyone. It's the billion-dollar mistake. It's cost the industry billions of dollars. And anytime we had a null pointer exception in Android apps, we'd get a crash. In this survey of over 1,000 applications, it was the most common exception. So this was a key data point that we really were socializing as much as we could, saying that Kotlin brings null safety to the table.
We also compared Java null checks with Kotlin null checks. So you'll see on the left a typical Java nested if statements with a lot of null checks. And then if something ends up being null, we just return null. That doesn't tell us anything. But if we were going to convert that same code to Kotlin, it looks a lot more fluent with the chaining and the safety operator.
So at this point, we've socialized the idea, kind of talked about what we like about the language, and then we really have to sit down and create a proof of concept to really show the engineers and have them feel the benefits of Kotlin that really make you fall in love with the language.
So we've mentioned Intuit is a big company, and when we want to make technical decisions, they usually come from our architects. So when they do that, they need to get buy-in from the engineers. They also need to consider things like a common tech stack and industry trends, because we need to find the balance of exploring new technology and then considering past decisions that we've made. However, when we introduced Kotlin, we were the first ones in our company who really wanted to use it, and we needed to convince those architects that this was a decision that they should make. When we were doing this in the beginning, we wanted to get feedback and kind of show off some of the Kotlin we had just started writing. So we set up a meeting with one of the engineers that was more senior to us who had experience with Kotlin, and we sat down and we wanted to show off kind of everything we've been working on, hoping that we can improve it. He ended up inviting a lot of the Java leaders at our company so they could kind of get exposed to what Kotlin was and see what we were working on. They had a lot of questions, and in that moment, we realized we were in our small bubbles of our team and what we were specifically working on, and we needed to account for the huge ecosystem that Intuit has. It's not just our specific team, and it's not just TurboTax. It's all of our products, and we need to make sure we're making a decision that's right for everyone. That transitioned us into forming a detailed proof of concept so we could answer any questions they had and be prepared.
So one of the key pieces we put in the proof of concept was data classes. This just right off the bat shows you how concise Kotlin is. You have a Java data class that you write, getters and setters. If you have a typo and copy and paste and you forget to change one of the names, you're going to have a bug. Kotlin data cluster is just concise. You're less error prone. It just really drives the point of why Kotlin is so great in terms of conciseness. And that was a great proof of concept for engineers and the architects to look at. On top of that, we also want to have proof of concept for functional programming. This is like, why do we want to use functional programming in our applications, and what is the benefit that it's bringing to us? So Kotlin has Lambda support, where functions are first-class citizens of the language. Java 8 has it as well, but Kotlin goes on top of that by having functions on the standard library collection. So you have the functions built in already for things like map, filter, fold, flat map, which really enables people to learn functional programming and use it really easily when they're writing Kotlin.
We started by using map, and we showed the comparison of Java map to Kotlin map. So you'll notice in Java, we need .stream, and then at the end, we need .collect. Whereas in Kotlin, you just simply do .map on the collection, and you can use the keyword it to make it even more concise. Similarly, filter is doing the same thing. You don't need that .stream or .collect, and you can use that it keyword again. When we were introducing this stuff, we didn't want to say, okay, everyone use every Kotlin feature you could ever imagine. We wanted to start slow and say map and filter instead of for loops with if statements.
So at this point, we have a proof of concept, some of the big features that we love that really drive the point of why Kotlin and functional programming is so great. Then we have to sit down and create a plan. So for my team, we had some hesitancy, so we had to go around and I had everyone say on a scale of 1 to 10, how comfortable are you with Kotlin? And I was expecting everyone to say around 4 or 5, and it surprised me when everyone said around 1 or 2. And it really showed that people felt low confidence, they didn't feel comfortable, they needed more practice, they needed more time. They've been coding in Java for 30 years or so, and they needed to build up their expertise more. So that's when we sat down and we said we need this training program to really prioritize our time. We already had all these other features we need to get done, so it really blocked out time on everyone's schedule to sit down and do an online training course together and learn the different key features of the language together. Then we sat down and we said, what are the goals that we want to accomplish with Kotlin? We first want to start with test classes. Those are pretty easy to convert with low risk, so we're not affecting any of our prod customers. So we started changing test classes into Kotlin, and then it built up some of the confidence. The next step was doing data classes. That's like an easy way to cut down Java lines of code, and you can add in a data class. Then the next step, which was the bigger step, was new features. We said all new features we want to write in Kotlin. And this made sure that we were all on the same page of the timeline we wanted to accomplish different steps and the milestones we wanted to reach. Then after that, we wanted to create a measurement for our impact. We wanted to see how is Kotlin really impacting our team and bringing us benefit. So one data point for that was when the features I wrote cut down the number of crashes by 60% in the app. That really showed this is creating higher quality applications, and this style of programming in Kotlin is really helping our production live customers. On top of that, it was also helping our developer productivity. It was allowing us to write the features faster for the developers to write, and then also less lines of code. So even at that point, we had been on the same page. Everyone was clear on the goals. We still can run into issues. I had one of the engineers on the team who is actually the tech lead. He'd been writing Java for years and years, and I was really excited when he decided to write his new feature in Kotlin. And he submitted a PR and had it ready. I reviewed it, and it looked pretty good, but I wanted a few more people to review it just to make sure everything was great. I sent it to Shelby, a few other people in the company that knew Kotlin, and had them review it. We had to get it merged in the next morning because we had to cut a release for the app, so we were in a bit of a time crunch. And so all these other engineers reviewed the code, added their comments, and the next morning, the engineer comes in, looks at his PR, and was so overwhelmed. He saw these comments, and he broke down, and he said, I'm just going to rewrite it all in Java. I'm not going to do this Kotlin thing. I really had to sit down with him and say, no, it's okay. Like, you did a good job writing in Kotlin. We need to just change a few little things. They're nothing big. We want to teach you the language by writing these comments in. But it was a big learning lesson for, him to learn new features, but also for us to take a step back and put ourselves in the shoes of when we were first learning the language and our expertise at that time and the journey it took to learn the features and slowly get there. So we really have to sit back and adapt to the different people on the team. We need to make sure we're helping them along the journey and bringing them along and not leaving them in the dust. So we really set up a feedback loop of understanding what is the comfort level on the team, what is everyone feeling like with the writing new features in Kotlin and making sure all of the issues were addressed.
So even with a plan and with defining what success looks like, we still need something to persuade people even more. And what's the best way to persuade an engineer? Data. So we use things like this with quotes from the Kotlin website that has a rough estimate that there's a 40% cut in the number of lines of code when you're converting code to Kotlin. And more concise code takes less time to write and, more importantly, less time to read. And so that improves your productivity and lets you get things done faster.
So one of the key data points is the boilerplate code and how much Kotlin reduces the boilerplate code in the number of lines of code. So here we have different features of the language, like type inference. You don't have to explicitly say the type of the variable. You have single expression functions, so you don't have to need the return body. You just have it look more like a mathematical equation. And then also string interpolation when you're writing out strings. So here is a Java function of getting the greatest cities. You have an array list with San Diego, since that's where we both live, Boston, because Shelby's from Boston, Seattle, because that's where I'm from. And then you're iterating through the array list and getting back the Boston, which is where Shelby's from, and then returning back that list. So to prove the point on how many lines of code this really is, we want to have Shelby write this out in Kotlin in a non-functional way. And we need some help from the audience on how many seconds you think it's going to take her to write this. Can I get some guesses?
Can we share the other screen up there? Can we share the other desktop? No? Okay.
No.
All right, so I'm going to do it, and Katie's going to time me, and you're going to have to trust me that this is what I'm doing. So ready?
Can we get some guesses of how many seconds?
15?
15, 30,
20?
20. Okay.
0.
Magic. Okay, I need everyone's help to say 1, 2, 3, go with me, and she's going to start typing, and I'm going to start timing. Ready? 1, 2, 3, go.
Done. So you were right.
2 seconds.
The reason why it was so fast is because I took advantage of my tools in IntelliJ. So we wanted to show you guys you shouldn't be doing everything manually. If you copy Java code into a Kotlin file, it'll automatically convert it for you. Or you can convert it by converting the whole file from Java to Kotlin. We used this as a tool when a lot of people on our team were learning and they were familiar with Java. So what they would do is just convert the whole file at first to look at the differences and then optimize later.
So also on top of that, we can cut the lines of code with writing it in a more functional way. So bear with us when we try to get the screen up there. But so we found it really helpful when we were teaching everyone also on our teams to do live coding with the team. And we can use the IDE and do all the cool tips and tricks and show them. It's a good way to sort of teach people the language, but also teach people the toolings in the IDE. A lot of people don't know things like you can do option enter. You can do the whole copy and paste like what Shelby just did, which is really helpful. So this is what she ended up copying, pasting, and turning it into Kotlin. in 2 seconds. That was a record time. So now we need a little more help from the audience. How many lines of code do you think it will take her to write this in a functional way in Kotlin? Can I get some
4.
guesses?
1.
1. Ambitious.
All right, let's try it out.
Let's see what she can come up with. All right, so she's starting at the function, returning a list of strings, and creating a list of the different cities. It's an immutable list. And then, after she has them all written, she's just going to call filter on it. And using the it keyword, she can check if the item in the list is equal to Boston.
So I think we can make this even better. It's 3 lines, but if I take advantage of my tools again and hover over the return keyword and click Option Enter, it'll give me this option to convert to an expression body. If I click Enter, it will highlight the return type, indicating that I can actually remove it and take advantage of type inference. So now we've got it down to 1 line. Good guesses.
Yeah, nice. So this really proves the data point that it's cutting down so many lines of code. It is so concise. It could help you with not only writing the code, but reading it. And then on top of that, we have other functions that you can use, like flat map. So we went over map and filter, but at this point, the team was starting to get a little bit more comfortable with the functional programming style. They're realizing whenever they have a for loop, they should just use map instead. Then we started introducing flat map, and that was like a little bit more for the team to take in, but you have a list of lists, and then we're iterating over the list and adding 5 to it. And on the left, you can see the Java code. You still need to do the collection at the end, but for Kotlin, it's a lot more concise. You have the flat map over the list of lists, and we have the inline operator of the plus to add 5 to the list, which adds 5 to every item in the list, which is awesome.
So all of these companies have Kotlin in production today, and this was another data point that we used to influence Intuit. Kotlin was also rated the 4th most loved language on the 2019 Stack Overflow survey. So all these things put together just helped influence all of the leaders. So even with sharing all these data and facts, there's still some myths that we need to deconstruct. It's important to break it down for people so you don't have false information spreading around. One way that we deconstructed myths was by writing a technical white paper. So this started out as an internal document for Intuit, and we really went through and explained what problems were we solving that we faced in Java. Through the process, we found it really valuable and got a lot of awesome feedback internally. And so we decided to make an external version of the white paper to help other companies influence to use Kotlin. So if you scan that QR code, you can read a blog post about our journey, and it links to our formal technical white paper.
So one of the myths we deconstructed is Java interoperability. A lot of engineers at Intuit are thinking, oh my gosh, we have to change to Kotlin, we have to refactor our whole application, and that's not the case. So we really had to break down to them, this is how the bytecode is generated. It just becomes Java bytecode. You have the standard library that's added in. You add that to your Gradle file or your Maven file, and then you can run your application with both Kotlin code and Java code. This was really nice for us to explain that you can incrementally add Kotlin into your application. It doesn't have to be a whole migration blocked off period of time where you're not developing new features. You can slowly add it in. We really took on the methodology of leaving some of our Java code that was still good the way it was, and then adding new features in Kotlin to really take advantage of the language. And anytime we need to refactor something, refactoring it into Kotlin.
We also had to make sure that Kotlin was supported with all of our tooling we used for Java. So we went through and put this in the white paper explaining that all of our build tools, all of our testing and code coverage tools, our CI/CD pipeline, and our IDE support was going to be just as good in Kotlin with no work.
Another thing that came up was, what can I use Kotlin for? A lot of people thought it was just for Android applications, and really had to break it down to them that it can be used for anything that runs on the JVM, so server-side applications with Spring Boot. You can use it on Android, you can use it on Kotlin JS, you can use it native, and these are all different IDEs. So this really opened things up to engineers, saying that we're not only just doing this for Android applications, but for server-side and other platforms as well.
Now, Kotlin's easy to learn, but we also found it a great tool to teach immutability and functional programming. One of the ways that Kotlin encourages immutability is when expressions. So here's an example that we showed people where we have a function, getNumber, and it returns the type string, and when a param is sent in with a 1, it returns a string 1, 2, a 2, and then if it's not, we don't know. And what's cool about this is if we change any of those branches to a different type, it'll be a compile time error. Also, we're never mutating the return variable.
Another good way to start using functional programming is using immutable variables. So Kotlin has it clearly defined by having the val variable as immutable and then the var variable as mutable. On top of that, with lists, if you want to create a mutable list, you have to explicitly type out mutable list of, whereas immutable lists is just list of, encouraging you to use immutable variables more.
So we're encouraging immutability and functional programming, but is that enough? Is our initial problem of what we were facing in Java actually being solved? This is where Arrow came in. On my team, once everyone was comfortable writing and reading Kotlin, we introduced Arrow. And Arrow is a functional companion to Kotlin's standard library. And we found that this continued to solve more and more of our problems. So some abstractions over Kotlin libraries here are option, try, either, IO, functor, applicative, and monad. And these are all very overwhelming and can sound very scary. And so it's important to note that we didn't say use everything in Arrow at once. We introduced it slowly and incrementally, just like we did Kotlin. So Kotlin's mission is to empower users to write pure functional programming apps and libraries built atop higher order abstractions. And this was really what we were trying to do and the problem that we were trying to solve of writing more pure functional programming apps at Intuit. So as I said before, we didn't start with all of them. The first type we started with was either. And this was a really awesome, easy thing for Kotlin developers to grasp because under the hood, it's just a sealed class. So an either is used to hold successful values. And you can define a right and a left. So the right is typically a success and the left is typically an error. So in this case, we have the right as an integer and the left as a string. So if we call either.right with a 5 sent in, the 5 will be wrapped in an either.right. And then if we send in either.left with a string, it will return a left with the string inside. Also, you can use map and flat map on top of eithers. So when you do that, it's only going to operate on the right side. So it will continue on and you can chain things and it will only operate on a successful value.
So let's take a look at how we can use this either type instead of throwing exceptions. These are 3 functions where we have parse. It takes in a string, and it's just parsing it into an integer. If it matches the regex, it will return back the integer. If it doesn't, then it will throw a number format exception. The next function, reciprocal, it will take in an integer. If it's a 0, then it will throw a legal argument exception because you can't take the reciprocal of it. Otherwise, it will take the reciprocal of the value and return back a double. And then we have stringify, which will take in the double and just stringify the double into a string. So let's see how we can change these to use the either type. For that first function, parse, we're going to return back the either type of either number format exception on the left, which is the error case, or an integer, which is the success case. So if the string passed in matches the regex, we'll return either .right of that string to an integer. Otherwise, we'll return back either .left of the number format exception. So that number format exception is wrapped inside of the either type. So we need some help from you guys on what you think will be returned if you pass in not a number to this function. Can we get some guesses from the audience? A left. Yeah, so left of number format exception. So this is what it would look like. It's going to try matching it to the regex. It will see it's not matched and return back the either left number format exception. So what will happen if we pass in a 2? Yeah, either .right of 2. So we're going to make it a little more challenging with some of these other functions that I was talking about earlier. So reciprocal, we're taking the reciprocal, returning back either of illegal argument exception or a double, stringify, returning back a string, and then magic is really putting everything together. Magic's going to return back either of the exception type or of string. So magic is going to parse the string, which will parse it into an integer. Then it's going to call flat map, so it will iterate over the success value. And then it's going to take the reciprocal of that value using the it keyword. And then we're going to map over that to stringify the value. So putting all these different pieces together. So what do you think we'll get if we pass in 0 to magic? Yes, either left of illegal argument exception, because you can't take the reciprocal of 0. Awesome. So what if we pass in a 1? Nice. Yeah, so we have either right of 1. And what if we pass in not a number again, but to the magic function? Yeah, the either left of number format exception. Awesome.
So putting this all together, how we would use this, we can actually, in a when expression, use smart casting to either .left or either .right and define what we want to do in that case. Here, we're also smart casting to the specific types of exceptions and then defining an error message that we want to return. So this is a function that we typically used to see in a lot of our Java services, and there's a lot of improvements we could make here. I'm sure you guys see some of them, but there's a lot of mutation of the integer status. There's some nested if statements. There's a try-catch. Something's throwing an exception. We're not sure just looking at this one function. And it can get really tricky when you're testing and when you're debugging. A way we can improve this using the either type is by defining the success state at the lowest layer of the code. So here we have a when expression, and when the status is 200 or 201, we're going to call that a success, and we're going to wrap the status in an either.right. You can also wrap the response body, a response object, anything you want, but what's important here is that this function returns an either, and at any other place in the code, you're going to know if it's a success or a failure. We can again do that same smart casting and say when the response is either .right, return a specific response message, and then if it's either .left, return a specific error message. Again, these were just 3 of the main things that we found from introducing just one type from Arrow. So imagine all the things we can do as we slowly, incrementally introduce more and more. We want to put the status checks at the lowest layer of the code. We want to handle errors with types rather than exceptions, and we want to avoid mutation.
So at this point, we've deconstructed the myths and told everyone this is really what Kotlin and functional programming is about. At this point, we can't stop, we won't stop, we gotta keep going. We'd reach our teams, but we wanted to get bigger and reach the whole company. That's when we started the Learning Community, where we would meet once a week for an hour during lunch at Intuit with Intuit engineers to talk about some of the key features of the language through presentations, live coding, code reviews, and then also going through Kotlin in Action, the book, to kind of find the best practices for the language. This really helped us build a community of engineers that were passionate about not only learning Kotlin, but also teaching Kotlin and using it on their teams.
Something we did in the learning community was open contribution and open source. So that's when someone from another team would contribute to my team's project, even though that's not normally what they work on. I don't normally work with them, and they also don't normally work on that tech stack. It's a great opportunity for people to learn this way through PR reviews, and it gets a lot of work done because it's work that my team has already defined by tagging help wanted or good first issue, just like you see in a lot of open source projects. It's just within Intuit. Overall, this has helped us empower different people on other teams to start using Kotlin, and then they can help us introduce Kotlin back to their teams.
So once we reached Intuit, we wanted to get even bigger and connect with the larger community. That's when we started reaching out on Twitter and Slack, finding people that were doing really cool things in the industry, people that were providing learning resources that we would share back with the learning community or sharing out things that we had worked on. And one of those things was an open source library that I did for Android UI. It's called Truffle Shuffle. It was written completely in Kotlin and with functional programming, and it was a way to show off some things that we were working on internally at Intuit, but then open source it into the greater community of Kotlin.
Also, attending and submitting to conferences has been a great experience for us. Last year, I actually volunteered here at KotlinConf, and I got to meet and see a lot of amazing speakers, which inspired us to come here the next year and speak to you all. We also got to meet a lot of people by going to conferences. Last year, I met Hadi from JetBrains and started talking to him about what I was working on, and he invited me to be a guest on his Talking Kotlin podcast. And so just putting yourself out there and going to events and networking with this community is how we kind of fell in love with the language even more and helped grow inside the company too. So we have a few QR codes for you all to look at. We were recently featured in Forbes talking about how to influence a tech company. So if you want to read more about our journey there, we'd love to get your feedback on that. We also have a Intuit Kotlin webinar with some other awesome Intuit engineers, and they share more about other places in Intuit that we have a lot of Kotlin. And then again, we wanted to leave that white paper link for you all to read and hopefully share within your companies. Next, we'll be speaking at KCON in March in Germany, and so we hope to see some of you there.
So now we've walked you through the 8 key techniques that we use to drive change at Intuit. First, finding what you're passionate about, socializing the idea, talking about it with your teammates, and sharing out your favorite features of that new tech. Then creating a proof of concept to really drive the key points of why you think that tech is so amazing. Creating a plan so everyone's on the same page on what goals you want to accomplish, the timeline for it, and the impact for your specific team. Then persuading with data, finding those data points to prove your argument even more. Deconstructing the myths on different preconceived ideas that people have in their head that aren't necessarily true. And not stopping there, keep going. Even when you get some issues, you gotta push through it. And then connecting with the larger community to share the knowledge even more and grow as a community. So we really wanna tell you that it's been a great experience for us. We've been able to reach so many people, and it only takes 2 people to start a movement.
Thank you.
Thank you.